Okay, so this is the challenge leg. Let's go over on how this was made. So first off, the secret sauce is let's make this sketch visible. So this tube, let's actually hop into this sketch. So on these ones, it's fine to have the weldment follow right along this line. Same with the bottom, same with the top. That's how it normally works. But on this one, on the bottom of the leg, you want the tube to be on the inside of this line. But on the top of the leg, the steel needs to be on the right side of the line. So in order to accomplish that, we need to make a diagonal line offset by half the distance of the thickness of the steel. So it's a 1/2 inch this way on the bottom, and a 1/2 inch this way on the bottom, and this line is what will actually be used for the weldment, which we can see here. So it follows that offset line on the top and on the bottom. So that's the biggest secret sauce, is doing an offset of half your distance so that you can have a diagonal line that way you can follow an actual shape or actual line for your weldment. If you don't do that, then on the top you're going to be sticking out too far, or you're going to be too narrow on the bottom. So you're not going to end up with a even offset on that and that corners. So right after creating the weldment, this is what you end up with. So you can see the corners are a bit funky. There's no end caps yet. That's all funky. So the first step was to trim this tube to this face. Next step was to trim this tube to this face. Next step was to delete that body right there. And now we have much cleaner tubes. The next step was to create a plane, which let's make that visible. And let's also turn on planes. Planes are on. Where is my plane? There it is. Okay, so this is offset a 1/4 inch down, which is my thickness of my end caps. The next plane should be the one on the bottom. Offset a 1/4 inch up. I will then do a trim extend of these two tubes to that plane to offset them up. Next trim and extend was on the top. These two tubes down to that plane. Next was a boss extrude, where I took a rectangle and extruded. Let's go ahead and show the sketch. So I took a rectangle of that cross section. So I drew from this corner up, over, down, over, and then extruded mid-plane for this and this. And at the same sketch, since we're going the same amount, I also did the bottom two. The next was a cut extrude, which what I did on this one, let's hop into the sketch. I grabbed this radius and did a convert entities. That way I had the profile of the tube. In my cut extrude, I then specified doing it through all, but I flipped the side of my cut such that instead of cutting the inside of the shape, I cut the outside. And for feature scope, I selected these two boss extrudes, and I mirrored this same concept on the bottom, since we're extrude cutting in the same plane on the top and bottom. Next, I made a plane coincident with the edge of my end cap and perpendicular with this tube, such that I could then do an extrude cut again with the same concept. So in my sketch, I took this body and did a convert entities. And on my extruded cut, I did flip side so that it was cutting on the outside of this shape. But for my selected feature, I saw I could only do this end cap and this end cap. After that, I made another plane. Let's go ahead and make that visible. I'm going to hide this one. I did the same concept on here with the same cut extrude. I then made another plane. And cut extrude on this tube. Since they are not in line with each other, they both need to be separate since this offset. And the final part, let's hide this plane and this plane. The final part was this boss extrude on the top, which I modeled in the holes and just extruded it so I didn't have to do an extrude and an extrude cut. And that is a brief examination of how I went about making this part. The next video will be step-by-step recreating this in the exact same process, but actually going through and creating the steps so that you can watch exactly how the process was done. In order to make it such that my dimensions were changed in one place, that rule is seen here. So I can change my 34-inch to 36. Oop, I typed 16. Let's make that 36. I can change my 14-inch dimension and rebuild, and you can see that it does not get crooked. And for my material thickness to be able to, so I wanted my material thickness to be able to be changed in one space. In this sketch, you can see that this offset is derived from a function. So what I did is under Tools and Equations, I have my steel width and height in a global variable, and then I have my steel offset as the steel height divided by 2. So in my weldment profile, instead of necessarily sticking with the original size that it says in the name, I actually go into the sketch, a normal 2, and I link this dimension and this dimension with this and this. So in this single table, what I'm able to do is by changing one number, I can change both my offset on my lines on top and bottom to get that diagonal true shape line, and I can change the thickness. So to give an example, we can go to Equations. Let's say my steel was 2 inches thick. We can see that that automatically updated. The offset is still correct. Nothing is misaligned. So the thickness changed, but if we go into this sketch, we can see that now the offset is updated from 1/2 inch to 1 inch, which is 1/2 the width of the steel, so that we can get that nice 1 inch offset on top and 1 inch offset on the bottom in the other direction, so that my sketch line is outside to inside versus top and bottom. So that is how you make this part. And then the only other thing that I normally like to do is, instead of doing my dimensions here, if I'm going to be using tables, I like to go ahead and enter this, or enter everything in the same table. So what we could do is we could say leg height, let's say 36, and then we can type in leg width, let's say 16, 16, and to link to those variables, we can go into our sketch, and under this, we can click equals, global variables, leg height, check. Exit out of the dimension tool, double click, hit equals, global variables, leg width, check. Now those are functions